Good day. Welcome to the webinar on pulses in dairy and dairy alternatives. My name is Tanya Director of Diversification and Market Insights with Pulse Canada. And today we're going to be looking at the latest innovative trends, research, and opportunities for pulses in dairy and dairy alternatives. I will start today's webinar with some context on the market. And then Janelle Carlin, Director of Quality and Processing at Pulse Canada, will get into the science behind pulse ingredients performance in a range of dairy segments. Now, before I start, I have a few housekeeping items to mention. You can chat with other attendees and ask questions directly in the chat panel to the right side of the stream. We've reserved some time at the end of the webinar to answer your questions. Note that we will be recording the webinar and circulating a link to everyone by email following the webinar. With that, I'd like to introduce Pulse Canada. We are the national association representing growers, traders, and processors of Canadian pulses. And through these webinars, such as today, we hope to stimulate ideas on how you can capitalize on the benefits of pulses in your business. In my presentation, I will cover the dairy market landscape. Then we'll look at pulse ingredient trends, followed by areas of innovation driving growth. So we'll talk about the dairy markets. The global dairy is an important industry valued at $668 billion US dollars. And as a whole, it grew quite significantly at a compound annual growth rate of 3.6%. And this is over the last 5 years. Now, the dairy category is a big one, covering many segments from baby food, butter, cheese, milk, and yogurt products, as well as ice cream. The plant-based dairy market, noted at the bottom here in the box, is valued at 21 billion US dollars. However, it makes up only 3% of the total dairy market. Now, conventional dairy products make up the lion's share of consumption and will continue to be an important part of diets all around the world. So plant-based dairy industry, it is, while being smaller, the category is forecasted to grow. The graph here shows global market value of plant-based dairy segments over the last 20 years. We've seen growth over the past 15 years, and more growth is yet to come over the next 5 years, with a CAGR as high as 10% for plant-based milks, that's the blue line that you see, or nearly 12% for plant-based ice cream in the orange, as an example. You can also see yogurt and cheese there. Now, Mintel published a study in 2023 showing what motivates US consumers specifically to purchase dairy alternatives. And consumers are expecting a lot. This graph shows that an important percentage of consumers indicated that the product needed to taste similar to milk. It needed to perform just as well, particularly from a texture standpoint. It needs to be less expensive, made from simple ingredients, and be nutritionally equivalent to dairy and so on. The list goes on. And consumers seem to be asking for a lot in their alternative dairy products, but there's a lot going on in the world that is really shaping this food category and the food category overall. Now, these are trends shaping the global dairy and dairy alternatives industry. Consumers, firstly, are facing inflationary pressures and are actively seeking value for their money. They want more for their money. And secondly, with health top of mind, there's a whole host of new functionalities that are on the rise, and this includes gut health as an example. Thirdly, clean label innovations will continue to be the gold standard. Sustainability is a trend that's not going away. There's pressures coming from all levels to reduce emissions. And lastly, consumers are feeling the fatigue and they want that special experience, and that's where permissible indulgence comes in. Now, I will introduce pulses, why pulses, and how they fit in the dairy landscape. And so I'm going to talk about the trends for pulse ingredients. And firstly, though, I want to just cover what are pulses. They are the dry leguminous seeds grown in a pot, and they include peas, lentils, chickpeas, and beans. They do exclude oil seeds such as soy and peanuts due to their higher oil content. These are oil seeds. And pulses are different from fresh peas and beans because pulses are harvested from the farm much later in the season, at least here in Canada. Now, pulses are a staple in diets all around the world, but they can be processed into ingredients in a range of ingredients. And this includes things like flours, which is grinding into a powder. We have fractionation happening. So you have your protein, starch, and fiber-enriched ingredients. You also have flakes and grits that have different particle sizes. So there's a variety of ingredient formats that can be used in all foods, but dairy in particularly, which we'll cover today. Now, why pulses? Very simply put, they're plant-based, they have clean label, ingredient potential, high protein content, about 2 to 3 times that of cereals on a dry basis. They also have a lot of fiber, minerals, vitamins, and that makes them very nutrient dense. And last but not least, they are also sustainable. So I wanted to just highlight a bit of sustainability benefits associated with pulses and pulse production. Pulses and legumes in general have the ability to fix nitrogen. So this means, this is shown in the image on the graph here, or on the slide here. Basically, they're taking nitrogen in the air and fixing it, converting it into the soil where the plants can use it to grow. And so this alleviates the need to use more fertilizer, which makes pulses are a really low carbon footprint crop. Now, pulses are also water efficient as they are adapted to growing in semi-arid conditions. And majority of the Canadian pulses grown here are produced with low or no-till practices, which help put carbon back into the soil. All this contributes to improved soil health, and because pulses are grown in rotation with other crops, the crops that follow pulses often get to reap the benefits as well from this fertile soil. So pulses have many benefits in terms of nutrition, but also the health of the planet is important, and this makes for a very feel-good story. Now, we're going to talk about pulse ingredients in the market. Here is a slide showing the new dairy launches, and this is global, and products, dairy products that contain a pulse ingredient. So this is essentially any new dairy products that show up on the grocery store shelves, and this is at the retail level, and this is global. Proteins, you can see here, are in the blue line, and they were the most frequently used pulse ingredient in these dairy innovations. It's followed by whole seed in the yellow line and flours in the green line. So there's been a real growth using a variety of pulse ingredients. We're going to dive into the proteins. This slide here shows dairy launches containing specific pulse proteins, and it's according to dairy segment. So essentially, peas and fabas, which are the blue bars and the yellow bars, they come out top in almost all segments, from alternative milks and yogurts to conventional cheese, cream, and creamers. And this is no surprise, as we're seeing a lot of these ingredients now gaining a lot of traction. We're hearing a lot about them. Now, those are proteins, and pulse protein specifically. I wanted to draw attention to other whole pulse use in dairy and alternative segments. This slide here is similar to the previous slide, but it shows the use of whole seeds or flours, so pulse flours, from different types of pulses. One theme here is that you see a lot of different bars here of different colors, which represent different pulses from chickpeas, lentils, beans, in the various applications. So for example, chickpeas are the orange bar, and they're being used a lot in cheese. Also beans, which is the peach bar, peach colored bar. It's used in yogurts. Faba beans are found in products like margarine, and that's that brown bar there. So the plant-based, so there's a lot of applications here. The plant-based drink segment, which is at the bottom there, is by far the most, is seeing the most activity in terms of pulse innovation. So basically, lots of different pulses being used in different applications, and Janelle will be walking through the different functionalities for these different products. But before that, I'm going to quickly give you a snapshot, a global snapshot of the products in the market and how they're being positioned. So I just have a few slides here, and it's going to mirror some of those top trends, those 5 trends that are shaping the food industry that I mentioned earlier, and starting off with delivering on functionality. Consumers will pay for added value. They might pay less, but they want that value. They're going to expect a functionality that fits their needs, and companies are responding. So brands are getting very specific on their product performance. So it's the end product performance, whether it's a foamy froth in barista milk, you see on the left here, or a cooking cream that's seen on the right side of this slide. And it's interesting to note a few things here. One, they are using whole pulses in both of these cases. And so they are really leveraging the functionalities of pulses to provide that specific performance that they're claiming. And secondly, they are also positioning, they're really positioning the functionality of the product, and not necessarily what ingredients are providing that functionality. So it's really functionality focused. We talked about health. There's an opportunity to position the functional health properties. And this slide here shows the share of new yogurt launches. This is Mintel data in the US, and it's segmented by nutritional or health claims. And I'm going to draw your attention to the probiotic claims on the left there. And the blue bar here represents plant-based yogurt, and the yellow is the conventional dairy yogurt, so animal-based yogurt. And you can see that 28% of new plant-based yogurts are positioned as probiotics. It had a US, it had a probiotic claim on a lot of these US products. And while conventional yogurts, that's the yellow bar, they are also being positioned as probiotics, but its share is not nearly as high as plant-based. And so we're going to get into a little bit more of this in the second half of the webinar. But I wanted to show an example, a commercial example of this vegan yogurt launched. It's in Thailand, and it contains a pea protein and chickpeas, and it's positioned as a probiotic that will help with the digestive system. So many companies are leveraging these claims around the world. Thirdly, clean label is here to stay. This company here from Germany has a super blend and a creamy blend. So these are the 2 products you see here. The products leverages the complementary protein from oats, and the combination of oats and chickpeas, as well as the almond and peas in the right product. And the product is said to be silky smooth and a source of protein, and it emphasizes the versatility, as you can add it to coffee, teas, smoothies. You can use it in baking. And so the companies are leveraging the functionality of these ingredients to create that value for that consumer. Moving right along, so we talked about sustainability was on the radar of some customers, maybe not all, but it wasn't the top motivator, particularly for dairy alternatives purchases today. Intel did do a study showing that these type of feel-good messages resonate more with the younger demographic. So it's Gen Z and millennials, and therefore there is an opportunity to be more bold with messaging targeted to this demographic. So I'm going to just quickly show a product here. So this product boldly states that it is carbon neutral, and it's not only explicitly showing this on the front of the package, it's front and center in the package, but the sustainability messages do slip into the back of the pack, and it makes up about 1/4 of the total surface area of this package. So they're using a lot of prime real estate on the pack to get their message across. And so this is a really bold tactic, and it's targeting a very specific demographic. Last but not least, consumers want enhanced experience. And so these brands allow consumers to do just that. So these are just some fun examples. Product on the left visually shows it's bursting with vitamins, and it makes you apparently want to dance. And the product on the right is a cherry cheesecake yogurt that contains bean flours. And the focus is really on the smooth, silky, creamy textures that provide that permissible indulgence that the consumers are looking for. And I did add a quick slide here just to show the different flavors that are being leveraged around the world beyond what we might default to as chocolate milk in North America. So in Japan, we have red bean and butter flavored soy milk. That's the one on the left. Next, we have white bean flavored. It's a dairy-based milk in South Korea, so it's a white bean flavored. And then we also have a vegan keto milk in the US that has a cinnamon roll flavor, cinnamon bun. And then lastly, there's a vegan cheese from Canada. It's an example that features miso chickpea to really accentuate that umami flavor that we like in our cheeses. So those are just some examples. And really this presentation here is just to give you a quick snapshot of what the market looks like in terms of pulses in dairy. And for just as a quick summary, we talked about plant-based dairy segment. It's grown. We all seen this in the supermarkets. It was really a niche, and it's become very mainstream. And pulses have played a role in this growth. There are a diversity of pulse flours and fractions that can be used to innovate these dairy products, dairy and dairy alternative products, and it could align with these consumer trends. And lastly, pulse ingredient usage in alternative dairy has global relevance. And I hope that some of this presentation here can spur some new innovation in your company. And so with that, that is my presentation. We're going to now have Janelle provide the latest research on pulse use in dairy and dairy alternative products. There's a lot of fundamental knowledge that's being developed in this space, and we have actually made an effort to summarize a lot of this in this webinar, but Janelle will lead you into the technical aspects of their use.
Perfect. All right. Thank you, Tanya. So as it was just mentioned, we've done a lot of work just in terms of compiling all of the research that's been done looking at pulse ingredient inclusion in different food applications. So a lot of what's being presented here today is really pulling from content that's been generated as part of what's called the Pulse Flour Hub. So here we're going to be focusing on dairy and dairy alternative applications and a lot of that research that's been published, but just wanted to highlight that we do have some information available on bakery and batters and breadings in this online database as a resource. So looking at dairy applications starting off, we've seen pulse flours and pulse ingredients being implemented across a range of different product categories. Today here, I'm going to highlight some specific examples looking at yogurts, fermented milks, cheese, and custards. So you can see here that there's a lot of different benefits that might result from pulse ingredient inclusion, whether it is used more as a texturizing agent based on water retention properties, gelation ability, viscosity enhancements. But we also see it being used in terms of supporting microbial growth. So whether that is the starter culture that's being leveraged in a lot of these fermented style products, or to support probiotic growth as well. So getting into yogurt specifically, pulse flours have been evaluated across the research at a rate of 10 to 50 grams per liter. And you can see here the specific benefits that have kind of popped up across studies. Getting into microbial growth rates. So as we look across the research here, a stirred yogurt that has been prepared with a starter culture or with probiotic cultures as well, do tend to exhibit appropriate ranges of pH and titratable acidity over a 21 to 28 day storage period with no inhibitory effects noted, just in terms of supporting that microbial growth. And if anything, as we look across the research, what we find is that inclusion of pulse flours do appear to actually have a stimulatory effect on microbial growth. So we're seeing things like increased titratable acidity, increased acidification rates, and increased counts of some of those bacterial culture levels. So diving into some examples of this, here we're looking at a stirred yogurt product that has been prepared with different supplemented legume ingredients. So on the right-hand side here, these are the two control samples where we have a rehydrated skim milk that has a total solids content of 11.5%. So this is control A. And then we have one that has been formulated to have a total solids content of 9.5%. So all of the samples that were supplemented with these ingredients did contain a base level of this 9.5%. And the ingredient was added to create a total solids content of 11.5% across all of these treatments. And what we're seeing here at the top of each of these bars is the pH after 1 hour of fermentation. And then as we go along and move down, you're seeing the proportional decrease after 4 hours of fermentation after each of these treatments. And then lastly, each bars indicate that a different yogurt starter culture was used. So yogurt starter culture A in the blue and B in the green, which are shown, the actual cultures are just on the bottom of this slide here. So as we look in the study here, you'll note that we did see an increase in the magnitude of the decrease in pH after fermentation by supplementation with a lot of these different treatments that were implemented. In particular, you can see that pea protein, lentil flour, pea fiber were quite successful in obtaining that decrease and that higher magnitude of decrease in pH, especially if you're comparing to the controls, which are just using that rehydrated skim milk powder. So taking another look at this is a study that looked at implementing chickpea flour into another stirred yogurt sample. So here we have 2 controls as well, which are using 3% skim milk powder and 2 different probiotic cultures this time, where when we're looking across the chickpea flour treatments here, there is 1 or 2% substitution of skim milk powder or a complete substitution at 3% chickpea flour inclusion. And then again, we're comparing its effects using 2 different prebiotic cultures. So here you'll note that for almost all of the samples that contain chickpea flour, there was an increase in titratable acidity. And this was also observed to increase over the course of a 21-day storage period as well, where in this case, there didn't seem to be as strong of an effect of the prebiotic culture that was implemented. So here, this is showing the actual counts of probiotic cultures from that same study from the previous slide here, where this is the probiotic culture 1 and probiotic culture 2. And you can see that every time a chickpea flour was implemented, there was a higher amount of total counts of these probiotic cultures in formulation, and this was maintained over the course of that 21-day storage period. So across studies, when we're looking at this stimulatory effect of microbial populations that does appear to be popping up, there are a number of different reasons that are hypothesized to be contributing to this effect. So one of them being just the fact that pulses might contain readily fermentable nutrients from proteins, oligosaccharides, carbohydrate components, which can serve as that starting food for the little microbes in formulation. We do see that pulse ingredients also have a lower buffering capacity than milk, which means that they require less moles of acid to decrease the pH by 1 point, which means that you can get a higher acidification rate. And some of the antioxidant properties and compounds that contribute to antioxidant activity in pulse ingredients might also play a role just in terms of helping to maintain microbial viability. So now moving on to the effects on texture, we do see that because of their contributions to total solids, that there is an effect on increasing viscosity and having a positive effect on the texture of yogurt formulations. So this slide here is looking at a control which implemented 2.5 grams of skim milk powder in formulation, and then you can see an increasing level of chickpea flour inclusion in these yogurt formulations, and that increasing that level of chickpea flour did result in an according increase in the viscosity of these yogurt formulations. How that affected then other textural parameters is that the same study here is shown on the bottom, where increasing the level of roasted chickpea flour inclusion, you saw at the higher levels of inclusion, there was statistically significantly higher water holding capacity for those yogurt formulations. And then what also happened was a decreased susceptibility to syneresis as you increase the concentration of chickpea flour as well. And then on the top hand side here, what we're seeing is just another example from a different study, which was looking at green lentil flour supplementation. And you can see here that both the native and the roasted green lentil flour did help to decrease that syneresis value. So this is thought to be mainly due to the water holding ability of some of the protein and carbohydrate components that are present within the pulses, their contribution to the total solids content as well. In addition, that because of their ability to help to reduce pH, because of that stimulatory effect that we did see beforehand on microbial counts, this might help to maintain pH at that isoelectric point of casein, which does result in that coagulation and texture development in yogurt products. So how did this affect the sensory profile here? So here we're looking at native and roasted lentil flour inclusion in yogurt samples compared to a control. And you can see that over the course of this 21-day storage period, there really wasn't a very large effect on the sensory products. One thing we do tend to find is that there might be a negative effect just in terms of pigmentation from pulse seeds on the color, as well as some undesirable beanie or off notes, which is something that did pop up when we were looking at the native flour. But in commercial applications, heat treatments are often used to deflavor pulse ingredients, and you can see here that the roasted lentil flour was successful in helping to improve some of those aroma and color notes to have them be similar to that of the control formulation. And one thing I also did want to highlight here is if you look across the 21-day storage period, there was an overall decrease in that overall acceptability from the control sample, which scored a little bit higher for those that contained lentil flour, and this is thought to be due to that effect on helping to decrease the syneresis of samples. So here, just looking again at a different study, the sensory attributes that were measured using a 20-panelist 9-point hedonic scale. So here it's again that supplementation of chickpea flour with skim milk powder and using prebiotic cultures here in formulation. And overall, at a 1 to 2% level of supplementation of skim milk powder, there was no statistical difference to that of the control. And only when you got to that higher inclusion level of 3% and completely removed the skim milk powder from formulation, did you see some slight decreases in the sensory properties as well. So there is some room to play around in terms of the inclusion level just to optimize and help to maintain some of those sensory attributes. Moving on to fermented milk beverages. So here we've seen pulse flours function and be applied at rates of 1 to 4% in formulation to get the following effects that are listed here on this slide. So similar to the yogurt samples, we do see that across studies, majority of these fermented milk beverages are aiming to have a probiotic style beverage, and that the majority of studies that use pulse flour supplementation were able to maintain and meet those minimum CFU counts to allow for that probiotic health claim. One study did note that using 3% lentil flour and a particular microbial strain, it wasn't able to support microbial viability over the 28-day storage period. But I did want to highlight that it does seem to be important to implement proper selection of starter culture strains or probiotic strains just to ensure that they do demonstrate an ability to grow and acidify in those particular mediums. So I just pulled one example here, which was looking at a lentil-based, plant-based milk and evaluated 7 different starter culture strains. And they did find that all of these 7 starter cultures were able to grow in this particular medium. So it is important to look at what strains are being implemented just to see if that they are able to grow in that particular medium. Looking at the acidification rate, so again, we do see another stimulatory effect of inclusion across studies. Where an appropriate starter culture was used. So here we're looking at 1 to 3% lentil flour inclusion compared to 1 to 3% skim milk powder inclusion, and a control which doesn't contain any supplemental additives here. And especially around this 10-hour fermentation mark, you'll note that the lentil flour samples had on average a little bit of a lower pH value than those supplemented with skim milk powder, and they were able to hit that target pH of 4.5 2 to 5 hours sooner than the control sample, and as well as the sample that contains skim milk powder. Looking at how it affects viable cell counts here. So here we're looking at a kefir style fermented milk product, which looked at just using a starter culture to obtain this product, and then also adding in 2 different probiotic cultures and then combining them for a 4th treatment. And then all of these 4 treatments were replicated to have an additional 4% inclusion of fava bean flour. So in the graphs here, the fava bean supplemented samples are those that are indicated with an F. And you can see that all of the samples that did contain that fava bean flour had higher cell counts in all of the products than their according samples which did not contain that additional fava bean flour. So this would be the same study and just looking at the effects of total titratable acidity, where again here we're noting that as a result of this fava bean flour inclusion, there was higher acid concentration in the samples. How does this affect the syneresis and the textural attributes of some of these products? So here we're looking at that lentil flour and skim milk 1 to 3% study again. You can see here that across the board, all of the samples that were supplemented with lentil flour had lower levels of syneresis than the control, and even lower than the samples that were supplemented with skim milk powder. So the one thing I did want to highlight here is that even the 1% inclusion of lentil flour had significantly lower values than a 3% inclusion of skim milk powder. So you might be able to get away with a little bit less additives in formulation here and still obtain similar results over this 28-day storage period. So the same study also subjected the fermented milk beverages to temperature stress that were heated and then subsequently cooled. And one interesting result that they found in this particular study was that there was a much less substantial reduction in the elastic and viscosity moduli for the samples that were supplemented with lentil flour. So here we're seeing a little bit less of a deterioratory effect of that temperature stress on the rheological properties of samples that were supplemented with lentil flour as you compare them to those, both the control and the skim milk supplemented samples. So there was one study that we found that looked at substituting starch in a custard style dairy dessert. So here, this particular study looked at an 8.3 to 11.3% inclusion rate of pulse flour supplementation. So overall, all of the samples that were evaluated were able to successfully replace starch in formulation, where we saw good viscosity and viscoelastic behavior and structural characteristics for all of the custards that were formulated in this study. And the inclusion of chickpea flour in particular did have a nutritional benefit in terms of increasing the resistant starch content of formulations. And the one thing I just wanted to highlight on the figures here is that this study looked at raw and cooked chickpea flour, 2 different chickpea varieties, and those 4 inclusion rates. And you'll just note that there are differences across the board just in terms of some of the characteristics for these custards. So there is some room for optimization of formulations by appropriate selection, appropriate formulation of some of these materials just to get those desired traits that you're looking for in particular products. Moving on to cheese. So here we've seen some pulse flours function in an effort to substitute raw milk or animal proteins in formulations or serve as a processing aid for water retention and helping to increase yield in formulation. So this is one study which looked at 1 to 10% supplementation of extruded chickpea flour as a processing aid in the formulation of a soft goat cheese style product. So you can see here the effect of sensory performance is presented in the table, where we did get, based on various levels of inclusion, differences in the consistency of the product. And if you took a look at the average sensory score rating, 5% inclusion rate is where the authors identified that to be the optimal inclusion rate in terms of consistency and average sensory ratings. So then after further evaluation of this inclusion rate, They did note that because of the water retention properties of that extruded chickpea flour, they were able to obtain a 12% increase in product yield compared to the control, which did not contain that chickpea flour for that production of the soft goat cheese style product. Here we're looking, getting into more hybrid products. So this particular study looked at lentil milk and inulin blends in an effort to replace some cow milk in formulation for a feta cheese style product, where dairy is very critical in terms of that performance and texture and sensory attributes for cheese style products at 20% or greater lentil milk inclusion. There did appear to be some undesirable sandy texture and poor performance of samples. However, at a 10% rate of lentil milk and 3.5% inulin, they were able to produce a sample that had acceptable sensory ratings and an ideal texture profile performance, and successfully substituted a portion of that cow milk in formulation, having an accompanying higher moisture content and water absorption capacity, which again could play a part in terms of processing yield here. So moving on to other hybrid style dairy products. So here I'm just kind of summarizing some key takeaways from a review that was published in Fermentation, looking at different pulse protein and dairy protein blends. And one thing that's important to kind of recognize here is that when we're looking at how plant versus dairy proteins might form gels, to develop that kind of texture that's characteristic of dairy style products, is that plant proteins do require a heat treatment typically in that process to be able to have that gelation occur, where multiple studies which have looked at blends of plant and dairy proteins to mimic conventional dairy style products are finding that they do tend to form independent gel networks of one another, which is not necessarily one cohesive three-dimensional gel protein network. And as a result, as you increase the concentration and the ratio of plant to dairy protein, there are some effects on the rheological performance of these dairy style products. So generally what was found is that there is a decrease in gelation temperature, gel stiffness, and at about 15% or higher, there does appear to be pretty significant negative effects on taste and texture and grittiness for these gelled samples, but you can at lower rates make some successful systems. And one thing I just wanted to mention here is that particularly across all of these dairy style applications, when we're looking at pulse proteins and particularly pulse protein isolates, the extraction conditions that were applied to produce that isolate are extremely significant and do dictate the performance of that pulse protein in formulation. So it's definitely important to evaluate and work with an individual supplier of pulse protein isolates, because their performance can vary quite substantially from one extraction condition to the other. Looking at some of the challenges that might occur, so these are some of the challenges that were presented again in this review, is that a lot of the studies that are looking at these hybrid dairy products don't necessarily look at formulations that would be typical of what you would find in dairy. So inclusion of lipids, inclusion of lactose, inclusion of flavorings. There were two in particular that were highlighted that might be relevant in the commercial setting, where one was looking at an 8% pea, oat, and lupin-based gel that was formulated with a 20% coconut fat. And they did find that pea and lupin were able to successfully create a texture that was characteristic of a cream cheese using this fat level. And then oat had a little bit more different characteristics, might be more similar to a mozzarella style product. And then on the bottom here, looking at a fermented yogurt style, hybrid yogurt style sample that was formulated with milk fat or coconut fat, and they were able to optimize those textural characteristics and sensory characteristics by the ratio of protein to fat, as well as co-cultures that were used in fermentation of these samples. So now, looking at the alternative dairy applications, we see a lot of opportunities for pulses and for pulse ingredients to be used in formulation. So here, highlighting plant-based milks, plant-based yogurts, and plant-based cheeses for the purpose of this webinar, where we do see them being implemented, again, because of their nutritional composition, for their gelling ability and effects on texture, and then for their ability to help and support probiotic and starter culture growth in formulation. So starting off with plant-based milks, one thing that we do note is that they are a really good alternative to soy to be able to produce a milk with a high protein content. So typically what we see across the board for a lot of these plant-based milk alternative style products that are from other cereal or nut bases is that they do tend to be low in terms of protein content. So using something like a pulse or a soy as a base, you are able to meet and get higher levels of protein content, albeit it might be slightly lower digestibility than that of soy, but you can reach similar protein content levels. So if we take a look at the preparation of plant-based milks, there are a lot of different opportunities to add pulse ingredients into solutions. So it can either be prepared from whole pulse seeds that are ground and separated and filtered to produce that liquid style milk base. So Tanya had showed a couple examples of commercial products that are implementing whole pulses in formulation, but we also see some research that's evaluating milks that are produced based on a protein or flour dispersion in water and producing a pea-based or a lentil-based beverage. And we also see them being used in terms of other ingredients to ramp up the protein content, to be used as emulsifiers in alternative-based plant-based milk ingredients, so adding it to a almond-based milk to ramp up the protein content. So there's lots of different opportunities to incorporate pulses into the preparation of plant-based milks. Particularly across the board for plant-based milks, there are a couple of challenges still in terms of some nutritional limitations if you're trying to compare it to conventional dairy milk. And there can be some issues just in terms of the sensory quality to emulate dairy milk again, and emulsion stability for these plant-based style emulsion products. So I'm going to review here just a couple examples of studies that have looked at ways to kind of optimize and mitigate some of those challenges, where this study here is looking at two different lupin varieties that were, so this is a whole seed lupin based milk that was wet ground, and then that filtration step to separate the solids from the liquid material. They used either a cheesecloth or a centrifuge to separate that material. And then that starting material was either a whole seed or a split seed. And you can see here that that separation step was critical just in terms of being able to optimize the protein content, where those samples that were separated with the cheesecloth resulted in a higher protein content on average than those that were used a centrifuge step. And also because of the effect of removing the hull, when you're having a split seed sample, that hull is concentrated in fiber. So just by default, you're concentrating the protein, and you have a higher protein content final product from using a split seed starting material than you do a whole. And you see that across the board here. This particular study looked at the effects of a high pressure homogenization step for it in terms of preserving and helping to increase that emulsion stability and colloidal stability of the system, where increasing the number of passes through the homogenizer and then also increasing the pressure of the system did help to increase the colloidal stability, and as a result of a decrease in the mean particle size of the system. One thing to note here is that there was a decrease in viscosity, and one thing that's been successful just in terms of helping to preserve stability of some of these emulsions and colloidal systems for plant-based is increasing the viscosity, as it hinders some of the gravitational separation in these systems. So as a result, some additives like thickening agents, gums have been incorporated into a lot of formulations and research just to increase viscosity and help to prevent and reduce gravitational separation. So I just wanted to highlight that here. But as a result overall of this decrease in the particle size, they also noted a lightening effect of pressure and of the number of passes of homogenization, which resulted in increased sample lightness because of increased light diffraction. And they did also note a decrease in microbial loads here. So looking at, here's another strategy, the effects of pre-treatments of the seed and how that influenced sensory quality. So this particular study looked at soaking alone, soaking and blanching, germination, and then germination and blanching, where you can see by looking at the sensory profile that blanching step in particular did help to significantly increase every single sensory attribute that was evaluated here, where germination was successful in increasing protein content, and germination and blanching combined did help to increase viscosity, sucrose content, and coatal solids. So as I mentioned on that previous slide there, increasing viscosity can be a strategy to help to improve stability of some of these plant-based milk systems. Another tool that they used to try to improve the sensory quality of these products was the addition of a 0.2% natural flavoring additive. So if you're comparing to the without natural flavors, these same processing and treatment conditions, you can see that there was on average a slight improvement across the board for some of these sensory attributes. And then I've just highlighted here a couple of different iterations of flavors that have been added and researched in formulation that have been found to improve the flavor and the sensory of some of these pulse-based milks. So here, there is also a couple studies which are looking at fermented plant-based milk systems. So here is a study that compared fava bean and chickpea-based milk and fermented that using a number of different starter cultures that are highlighted here, where there were significant differences just in comparing pulse type. That fava bean samples did tend to demonstrate lower syneresis, had higher titratable acidity at a similar pH value when compared to chickpea, but there was an off coloration for fava bean samples, so a lot less lightness, a little bit more grayish tinge to it for that milk. However, when they fermented the samples, that did help for fava bean in particular to increase the lightness value of those milks that have been derived from fava bean. And there were differences just in terms of their rheological structure as well that are highlighted here. So getting into plant-based yogurt, so fermentation of some of these plant-based milks that you can produce from pulses can produce a yogurt-style product. So pulses, again, because of their ability to gel and contribute to viscosity, they can be a suitable base for the production of plant-based yogurt formulations. Here, again, they are a high protein alternative when you're comparing plant-based sources to produce these style products. So this is just a figure from a review article that was looking at different plant-based yogurt formulations. And you can see here the contribution of pulses to that total protein content samples. And it's similar to soy here. And one challenge that was highlighted here in terms of plant-based yogurt formulations is obtaining that desirable texture that it has that ability to adhere to a spoon. And they did offer a number of different solutions in this particular article, such as structuring agents, which can help to contribute to texture, heat treatment optimization to really refine and get in on that optimal gelation of the proteins, or starch gelatinization. One tool that was highlighted that's used in conventional style yogurts is the use of lactobacillus strains that have the ability to produce exopolysaccharides. And those polysaccharides can actually help to contribute to texture, although this hasn't yet been evaluated for pulse-based yogurt style products at the moment. It is a tool for that conventional style yogurt. One thing they'll referenced is not only do plant-based proteins gel after heat treatment, but there is commercial production using salt-induced distillation. So calcium or magnesium salts are used in the production of tofu. So potentially something that could be evaluated as a tool to obtain texture in some of these plant-based yogurt style products. So here, this is looking at a plant-based yogurt that was developed and formulated using a blend of chickpea flour, lentil flour, and rice flour, and they fermented it using the following strains, where overall the sample was positively received. It had acidic and creamy notes and that viscosity characteristic of adhering to a spoon, and it remained stable over a 30-day storage period and proved to be an acceptable carrier for probiotic cultures. The one thing I did want to note is that fermentation was able to significantly increase the nutritional value. So this study in particular took place in Europe. So they looked at the nutritional index here, and you can see that that increased substantially. We also saw improvements in terms of the in vitro protein digestibility as a result of fermentation, then, and also successful in the reduction of some of the anti-nutritional factors that might be hindering some nutritional digestibility in some of these plant-based style products. Looking at plant-based cheese formulations, we also see pulse flours and pulses being used across the board. So this is just one example looking at pulse flour. So here we're looking at a boiled or roasted yellow pea or fava bean flour to try to emulate a Gouda cheese style product. So here they were able to optimize the texture of these samples using different levels of water to flour ratios, as well as different levels of this kappa carrageenan stabilizer, where all samples were able to produce a sliceable effect and had a higher hardness value than this reference Gouda cheese. Well, it was lower than a commercial vegan cheese analog that they bought and used as an alternative control, where all of these samples did have higher protein, higher fiber and fat than that commercial vegan cheese that was evaluated, but not the same and not comparable nutritional characteristics to that conventional dairy-based cheese. And here you can see that boiled yellow pea flour did have the most similar resemblance and hardness and chewiness textural characteristics compared to that Gouda cheese sample, where the others did have some discoloration. On the fava bean here, they attributed this largely to using whole fava bean flour and not dehulled. So the presence of the hull did contribute to some dark spots in formulation, which it would be interesting to see a dehulled flour be used in formulation as some future steps forward. So here, this is looking just at pea protein-based gels that are fermented to produce a plant-based cheese-style product. So it's a series of publications from a research group looking here initially at different levels of pea protein and olive oil, so adjusting that protein to fat ratio. And they did find differences just in terms of the gel characteristics and rheological performance of these gels, where 10% protein and 10% oil was really identified as the combination that resulted in the best rheological performance. Here, looking later at different oil formats, so sunflower oil, coconut fat, oleosomes, and oleogels in formulation, where they didn't necessarily find many differences in rheological performance across. And then also being able to optimize further some of the sensory and textural characteristics of these gels based on using different starter cultures and adjuncts for that fermentation step. So that resulted in differences in acidification rate, the texture, and also volatile organic compounds that are associated with beany or dairy-like flavors. So really being able to kind of select the cultures to balance and produce the optimal quality product. So with that is going to be the end of my presentation here. And I'm going to pass things back on to Tanya.
Great. Thank you, Janelle, for taking us through the latest research on pulse performance and all those different dairy and dairy alternative segments. There was a lot of information there, and we do have a number of questions here, and we have just a few minutes here. And I think we could maybe tackle a few of these, and we'll start with, if we're ready to start. Laura has asked, could the pulses be used in plant-based beverage without milk? And so I know you covered some of that, but maybe you can comment on the dairy and the dairy alternative categories and how this research plays in both of those areas.
Yeah, so there was research that evaluated it both in that conventional fermented milk style product as well as the plant-based beverage, but just given the diversity of pulses, pulse ingredients, ingredient options, there is a lot of opportunities in a lot of these different beverage categories to utilize pulse ingredients. So that's kind of maybe how I would answer that.
Okay, perfect. There's another question here, more on the isolates. So how do you see the use of isolates in the production of pulse milks and yogurt? So I think it's just overall feedback, and I'm not sure what they mean by producers, but just I guess isolates in the production of pulse milks and yogurts. There's a lot of use right now. Any comments on that, Janelle?
Yeah, it's one of the larger categories in particular for pea protein isolates is its use in beverage, where we are starting to see a little bit more now. I would say that some of the commercial manufacturers of isolates are really tailoring their production to optimize the pea protein performance, in particular for the production of some of these dairy alternative solutions. So I think our knowledge base and the knowledge of the industry is really growing in terms of that as an application. And there is a lot of success in using those style of isolates in these food categories. So I do see it being an area where there will be growth. It's a good alternative base ingredient and something to help boost the protein content. And Tanya mentioned there too, especially if you're incorporating it into a cereal base or a nut base, we do see that protein complementarity as well. So that's something that is beneficial when you're looking at pulse isolates and formulation.
Okay, great. Yeah, so there's a whole host of ingredients that can be used in dairy and dairy alternative products, and it's a lot about functionality and positioning. So we have an interesting question here. For those, how do you control the denaturation of protein from pulses from UHT treatment? So that's ultra high temperature treatments, products that have to undergo those conditions. How do you control for denaturation? Any comment on that?
Just looking at different combinations of time and temperature to try to minimize that effect. You're ultimately going to get some denaturation. It's when you're implementing those high temperatures, it's likely to occur. So just looking to optimize the conditions that are being applied.
Okay. We're getting a few more questions here, and I think we are going to maybe do one more. I'll just do the next one up here. Could you share more details on the soaking and blanching process?
So maybe on that, all of this will eventually be summarized in that Pulse Flower Hub that we referenced earlier on. So you should get a link following the webinar here that will link back to the Pulse Flower Hub, which will contain a synthesized version of everything that was presented here, including all of the sources that were referenced. So you can kind of really use that as a good source to get into the literature and go back and pick out the ones that you may or may not want to read in depth there. But also you can reach out to Tanya or myself, and we're happy to do that too, and do it for you and talk a little bit more about the data.
Okay, perfect. And maybe this is a good time. We're on the half hour now, so we'll wrap up. There's a few more questions here. We will follow up with those questions, as Janelle mentioned. We will be circulating the recording of this full session through email. There was also a question about the slides, and we can arrange for that as well. So just having the slide deck, access to that. We, as Janelle mentioned, we have that Pulse Flower Hub. You can actually scroll down on this page right now and access the link there. The dairy content that you saw today will be going live shortly, not right away here, but it will be coming up. And so we'll include this along with the recording when we email you. In the meantime, you can go in there and access the bakery and batters and breading content. And we'll be continuing to add more content to that hub as time progresses. And we also we hope that you can complete a short survey on today's webinar so that we can work to provide more value to you at future events. So with that, I think I'd like to thank all of you for taking the time to join us today. And we'll just conclude our webinar for today. And I hope you have a wonderful day. Thank you.